Yes, student, is it audible? Okay. Today our topic will be lever rules and fractional distillation. The figure shows in the slide is figure number 1. Figure number 1 is the lever rule in liquid. Lever rule in liquid, vapor, equilibrium. Figure number 2 is it is a theoretical plates of fractional distillation. Suppose consider a two-component temperature diagram of A and B. We are considering a two-component temperature composition of A and B. Suppose if we assume B as a liquid and A as a vapor. So if we draw a line between the mole fraction and temperature, mole fraction XA and temperature T, the liquid phase L, liquid and vapor phase. So this B is more volatile as compared to vapor because this liquid can turn readily into gas phase. So B is more volatile as compared to A. That's the boiling point of B. B is more volatile as compared to A. Thus the boiling point of this B is less than pure A. Since it is more volatile, its boiling point is less as compared to this pure A. Because of that, this dA is written in the downside and Tp is in the downside and dA in the upper side. Suppose in the two component system of liquid and vapor phase, that can be determined by this lever rule. So a line is drawn between this component vapor phase and this liquid phase. A line is drawn, horizontal line is drawn between these two, and the midpoint is denoted by A, and this line A is called tie line. Where the liquid and vapor is meet in the point in equilibrium curve. So the liquid L from here to here, this V to A, this part, and L to A. this vapor phase. This part is a vapor phase, and V2A is a liquid phase. And the component of this liquid and vapor can be calculated. So this N liquid equal to divided by N vapor. This liquid phase is the length between A from this point, tie line to this liquid phase is length of between A to V, and vapor phase is the length between A to L from this line. Then the amount of ratio of liquid and the vapor can be calculated with the help of this ratio equation, and this is called lever rule. If you consider a two-component system of solid and liquid, at that time this liquid will become solid and this will become liquid. But here we are considering a liquid versus vapor two component. So this is all about the lever rule. The figure number 2, this is a theoretical plates of fractional distillation. Here also we are considering a temperature versus mole fraction of component A. Mole fraction versus temperature T. So with the help of this diagram, we can use this lever rule diagram for illustration of fractional distillation of two liquid. Suppose if a liquid, it can be any of the liquid like water or acetone, any liquid, composition of a mole fraction in the X1 is heated to temperature T1. The vapor of the composition X2 is observed. And later on again, when we heat this composition X2 at T2 temperature, on cooling and condense, this X3 is observed. And again it is heated at the T3 temperature and let it cool, and until it reaches a P, temperature point P is obtained. Thus the vapor phase at temperature this T3 is further cooled so that we can observe a pure liquid. P. If we meet at the point representation of this point dP of a pure P. So that is all about the theoretical plates of fractional distillation. So in simple term, the mole fraction versus temperature T, you have a liquid, you heat it and let it at this T1 temperature and let it cool by adding some condense, and after some time when it cools, you heat it until the pure P is observed. So this is all about the theoretical plate of a simple distillation step in which equilibrium between the solutions and the vapor is established, and the vapor is contains the liquid of different opposition, that is shown in this figure number 2. Minimum 4 theoretical plates are sufficient to obtain a pure liquid of any given compound. So that is all about the lever rule and the fractional distillation. I've also given a theoretical note. You can push the video and go through it for your more clarity. Lever rule. Lever rule. This is the equation where we can obtain, and the fractional distillation. You can pause the video and go through. Everything is written what I have explained. So that's all for today. Thank you.